Hello, this is Mr. Stansbury. I'm going to take you through the 10C notes on trigonometric problem solving. So, at the end of this, you should be able to say I can solve real-world type problems using trig ratios. All right. So, first thing we're going to want to know is the different angles there are. So, from the horizon, if you are looking up, that's considered the angle of elevation. If you're looking down from the horizon, that's angle of depression. And then also angle of elevation is if you're looking up to the horizon as well. All right, so with that, let's take a look at an example. This is similar to example 9 from page 328. This is find the height of Birdzilla if she casts a shadow of 12.4 meters when the sun makes an angle of 52 degrees to the horizon. So excuse me, let's take a let's make it a little easier to work with drawing here. So there's Birdzilla. Here's our angle. Here's our right angle here. So this is Birdzilla's height. She casts a 12.4 meter shadow. So basically the sun is up here casting this shadow off the top of Birdzilla, and when the sun makes an angle of 52 degrees to the horizon. So we want to figure out what that is there. So that's the big part of the problem here usually, is just trying to figure out the setup, what the picture looks like. Alright, so once we have that, we look and we need the opposite side and we have the adjacent side. So that would be tangent of 52 equals opposite, which is question mark Birdzilla's height over 12.4. So we get this, and we're going to multiply both sides by 12.4. Right? So let's bring up our calculator and calculate this thing out. So let's do 12.4 times, well, you don't even have to push times, just do tangent of 52, and we get 15.87 meters. So question mark equals 15 point, let's do 15.9 meters. So Birdzilla is about 15.9 meters tall. That's a pretty big bird, as you can see. Pretty destructive bird here too. Notice all the buildings and flames and smoke, and that's someone running off. So that's Birdzilla. Let's take a look at some more examples here. So calling this example 9C. This is like number 8 from page 329. And it says Trixie measures the angle of elevation to the top of the world's largest venti sugar-free non-fat vanilla soy double shot decaf no foam extra hop peppermint white chocolate mocha with light whip and extra syrup ever made as 33.1 degrees from a point that's 150 feet from its base, and then she walks until she's 50 feet from the base. What's the angle of elevation now? So be handy to have a little picture here. So I kind of redrew this here already with a picture, because you know how difficult it is for me to make circles and straight lines. So this is as good as it gets. So with this here, again here, she's standing 100 feet from the base of the cup. Okay, and it says the angle of elevation is 33.1 degrees. So then she walks till she's 50 feet from the base. Now we want to know what that angle is there. So excuse me, what we really want to do is we want to figure out what this height here is, because if we find out this height from the big triangle, you can then use that height to figure out this angle here. So if we look at just the big triangle, let's see, we got 33.1. That's supposed to be a 3 and another 3. There we go. And then this is 150 feet. We want to figure out what the height is there, right? So let's see, that's opposite and adjacent again. So we'll do tangent 33.1 equals h over 150 feet. Right? So again, we want to get h by itself, so we're going to multiply both sides by 150 feet. 150. So then we bring our calculator back up again, and we do 150 tangent 33.1, and we get 97.78. So let's go 97.8 feet. All right. So this here, 97.8 feet. So now if we're looking for this angle here, let's do that over on this side. We know that this is 97.8, this is 50, and we're trying to figure out what that angle is there. So again, it's opposite and adjacent, so that's going to be tangent. Tan theta equals 97.8 over 50. So when we're going to calculate, trying to find an angle, we will actually do second tangent of 97.8 divided by 50, and we get 62.9 degrees. So we get this angle here, 62.9 degrees. So that's the new angle of elevation to the top of the world's largest coffee. We'll call it that. All right. One last example is this one. It's example 10 from page 330, and it says a builder designs a roof structure as illustrated. The pitch of the roof is the angle that the roof makes with the horizontal. Okay, so find the pitch of the roof. All right, so what we're looking for then is this angle right in here. That would be the pitch that it makes. So what we're going to want to do is that's a terrible line, but basically cut this into a right triangle. So if this is 1 and this is 13 and this is 1, that means from here all the way over to here is 15 feet, the whole base of this triangle here, right? Or 15 meters. So half of that then would be 12.5. So redrawing our triangle here a little bit bigger so we can see it better. I don't know what it is about going up and down. I just can't make straight lines that way. But so this is 12.5 meters. This is 8. Half of 15 is not hardly 12.5. Sorry, that is 7.5. Don't ask me where I got 12.5 from. So let's see. Let's erase that and put that as what it should be, which is 7.5. All right, and then that's 8.7, and then all we have to do is figure out what that angle is. So we have the adjacent and the hypotenuse, so that tells us that it's going to be cosine. So cosine theta equals the adjacent, which is 7.5, divided by the hypotenuse, which is 8.7. So again, we call up our calculator, and since we're looking for an angle, second cosine 7.5 divided by 8.7, and we get 30.45. So let's call it 30.5 degrees is our angle. All right. So pitch of the roof is 30.5 degrees. All right, that's all there is. You should now be able to say that I can solve real-world type problems using trig ratios, especially real-world type problems involving giant, giant chicks. All right. If you have any questions, please ask. Thanks.